Hello guys, so today we are going to start a new topic which will be one of the topics of calculus. Okay, in your book it is not given as calculus, okay, but the chapters are from calculus. So the first one I'll be doing is, the first topic in calculus is continuity, and then you'll have differentiation, okay, then you have integration. So these three things we will be studying in class 12. Okay, applications also we'll see application of this, application of this. This is we will do in class 12. Okay, before moving to these two, you should know continuity, and to know continuity, you should know limits. Okay, so today I'll be teaching you limits first. It's a small video. Okay, so I will teach you limits first, and then we will start continuity. So limit of a function. What do you mean by limit of a function? If I say that limit of a function is 2, okay, what do you understand by this? Let's see. So it is that value which a function, okay, we represent functions as fx, so which a function approaches if the variable in the function, not this line, which is the variable in our function, this x is the variable in our function. So it is that value which a function approaches, this function approaches some value if the variable in the function approaches a given particular value. By that we mean if the variable in the function, which is x, approaches some value, okay, and with this x approaching to some value, okay, some value, this fx approaches to some value, right? We will see if fx is equals to 2x plus 3. Now you tell me, if my x is 2, then what is my fx? 7, right? So when x reaches to 2, our fx reaches to 7. So limit of the function means it is that value of the function, okay, which is obtained when our variable in the function, when the variable in our function approaches a given particular value. Understand? This is how we understand what is limit. Now let's see an example. If your example is asking you that what is the limit of this function, this is our function, okay, this has a variable x can take any value, so we can call it a function with respect to x. Okay, now without using this limit, let's see where this function approaches when I go to 1, because our definition says that it is that value which a function approaches if the variable in that function approaches a given particular value. Okay, so what is our given particular value? That is x is going towards 1. Okay, and simple idea to understand is x is equals to 1. Okay, so what will be our function if our x equals to 1? Clear? So now let's not do like that. Let's see without the limit. Okay, so I am expanding this limit in these forms. So what did I do? I took x as 1.1. Okay, now I substitute this x here, Now if I substitute wherever there is x, this is my function. So wherever I have x, I will put 1.1. Okay, so when you solve, you can see how to solve. 1.1 square is 1.21, 11 square is 121. Okay, so 1.1 square will be 11 by 10 whole square, which is 121 by 100, which will give me 1.21. When you solve, you will get, see what you are getting. The step 1.21 minus 1 divided by 0.1, and then for this point I have substituted 0 here, and this point I have given 2 zeros here, so ultimately I get 2.1. Okay, let's come more closer to 1. Suppose I have a line like this. See, this is my 1. Okay, now 1.1 may be here, 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, 1.7, 1.8, 1.9, and then this is 2. Okay, so 1.1 is here. This is my value, 1.1. Okay, now I come more closer to 1. I took 1.01. 1.01 will be somewhere here. Okay, very near to 1. So when I take 1.01, let's see what happens. Okay, see, when you square this one, you will get this. Okay, when you square this, simple idea is this: 1.01 can be written as 101 by 100. Now square them and then write it. Okay, so we are getting this. You will see as my x value. This is x, where this is the line where I'm plotting x. So as x is coming near and near to 1, our fx is going near and near to 2. Can you see that? This is 2.1. Okay, and this is 2.01, more closer. 2.1, if this is 2.1 will be somewhere here, but 2.01 will be somewhere here, near. So as you approach to 1, then your values will approach to 2. Clear? So this is our limit. So how do we write it? So we can say as x approaches 1, the function approaches 2. Therefore, the value of the given function is 2. Okay. In other words, how do we write? So we can write this: limit x tending to 1, x square minus 1 by x minus 1 equals to 2. Okay, understand? Now the question is, what happens when x is equals to 1? Because I said that when x is approaching 1, then our fx, which is here, can you see this? It approaches 2. Okay, so what happens when x becomes 1? Okay, try putting here x equals to 1. This is 1 minus 1. This is comes with 0, and this one 1 minus 1. This also becomes 0. But I am saying this. Okay, how can this happen? 0 by 0, but here we are getting 2. Okay, so let's see what happened here. We'll tell you, but slowly. See. Now, suppose if I have an example here. This is our example that limit x tending to 3. What is the value of this function? What is given? Simple, x equals to 3 is given. So here, directly you can put your 3. 3 square minus 2 multiplied by 3 plus 1 equals to 9 minus 6 plus 1. So this is 10 minus 6, which is 4. So the limit of this function at x equals to 3 is 4. Okay, but why here we did not substitute 1 directly? Why? And after our answer is 2, but we got 0 by 0, right? So let's see. Suppose this is our example. Now this is 25. Please correct. This portion is 25. Okay. And the question, let me rewrite the question. Limit x tending to 5. Okay. And this is x square minus 25 by x minus 5. So you try putting 5 directly here, you will get 25 minus 25, that is 0, 0. So whenever you come across a situation like this, you will not substitute the value directly. Here you don't have a situation like that, 0 by 0. So you can directly substitute. But here you have 0 by 0 form, so you will not substitute directly. In such cases, we will try to simplify the problem before substituting the value of x. Okay. So in such cases, how do we simplify? See. So here we have 25. So can I write this 25 as 5 square? So can I write this as square here? This part, can you see? Can I write x square minus 5 square? So this is a square minus b square formula, which is a plus b and a minus b, right? So you write here, and then you see this and this will get cancelled, and you will get x tending to 5, x plus 5, and when you put your value, you will get 10. Okay, so this is what happened in the previous problem. So in both these cases, you can see here also you put 1, it will become 0 by 0. That was our first case. But if you solve it like this, if you solve this problem like this, you will see your answer will be 2. Okay, try doing the same here, you will see that the value will come out to be 2. So for this, the value is 2. Clear? For this, you will find out yourself. Okay, because you should know the formula for x cube minus y cube. Okay, you know the formula x minus y, x square plus xy plus y square. This should be your formula. Okay, so before proceeding, once you try this problem, okay, see the answer. For this, the answer should be 2. Okay, for this, you need to find. Okay. Okay, what is next? So now whenever we encounter a situation where we have 0 by 0 situation, or we have a value which is undefined. Okay, in limits, whenever you reach a situation of 0 by 0, or we get a value which is undefined, suppose here you see, if you put x equals to 2 here, 0 by 0 situation you have seen, which is here also and the previous slide also. So in that case, you will get 0 by 0 is not defined. Anything divided by 0 is not defined. Okay, so here, this is one case where you will simplify. Okay, this is another case where you will simplify. Suppose if you have 1 minus 2 square. Suppose I put x equals to 2 here. So what are you getting? Minus 3, which is not defined. This is a complex number. In class 11 you have learned. Okay, so this is a complex number. Here we are dealing with the real numbers. So this is not defined. Okay, so if you are having a situation like this, you will simplify it and then solve. Okay, mostly you will get like this in limits. Now, rules of limits. In some cases, we get situations like this, 0 by 0. Okay, suppose a simple classic example if I get, I say limit x tending to 0 sine x by x. This case, see, sine 0 by 0. Sine 0 is 0 by 0. We are getting this kind of case. Okay, but we have found out a formula with which we can get this as 1. Okay, it comes from infinite series. if we use infinite series, then we can see that this limit of this should give us 1. Okay, so infinite series, if you wish to study, you will have later in degree, so here not required to show you infinite series. Okay, so the first one is, whenever you have a situation, I'll show you a problem on each of them. So whenever you have a situation like this, x to the power limit x tending to a, x to the power n minus a to the power n by x minus a, this should be written as n a to the power n minus 1. N is this power, a is this to the power n minus 1. Okay. Next one, limit x tending to 0, and you can see in every cases you will see that it becomes 0 by 0 form. You will see in this also, you put x equals to a, so a to the power n minus a to the power n should give you 0, and then a minus a should also give you 0, so this form. Now here you see a to the power 0 is 1, 1 minus 0 is 1 minus 1 is 0, and this is 0. Okay, so this is also 0 by 0 form. So if you encounter a problem like this, you will use this formula. Okay, now you have to by heart. For the proof of this, we have to leave our topic and go to something irrelevant to us. Okay, so that's why I'm not going to the proof of these formulas. The one which I said. Okay, this has also come from infinite series. Okay. Now focus something. What x is here, that x is present here as well as here. What x is here, see x is present here and a is present here. You should try to find the exact thing in your problems. Okay, so here you see if there is x, here should be x, here should be x. Then only you can apply this formula, otherwise cannot. Here mx, so you should get mx here and you should get mx here. Clear? So similarly, you see tan x also it's same, tan mx is also same. Okay, the next you can see this we rarely use these. Okay, so you see limit x tending to 0, mostly used are these, this one, okay, and sometimes this. Okay, now log 1 plus x by x, x tending to 0 should be 1, and limit x tending to 0, 1 minus cos x by x should be equal to 0. Okay, now let's see fundamental theorems on limit. Fundamental theorem is very easy. It's just, if you see that if you have two functions in addition form, and there's a limit outside for them, this limit will go to this also and this will go to this also. You can see here, split it. Okay, if it is a subtraction, it is same. Okay, provided both the functions here should be a function of x. You can see because x is going to a, so both, if those who are function of x, there you have to apply limit. Okay, suppose here you see this c is not a function of x. Clear? So what happened when you apply limit here? What happens when you apply limit here? C comes out. Can you see? C comes out, and whichever function is there having x, the limit will be applied to that. Okay. Similarly, here you see in place of c there is fx now. Now see, limit is applied to both of them. Okay. So this is fundamental theorem of limits. Now let's see. Let's solve each problem. So this is our formula and example based on this. Okay. Now you see. Here you see x to the power 4. And this one can be written as 5 to the power 4. 5 into 5 multiplied by 5 multiplied by 5. 25. 25 5 times 125. 125 5 times 625, right? So I can write like this. How I can write? Limit x tending to 5 x to the power 4 minus 5 to the power 4 by x minus 5. Now you can see this is same as this formula. Can you see? X is going to A, and here there is x, here there is A, here there is x, here there is A. Clear? So exactly same here. See? Okay. So now what I can write? NA, 4 into 5. This is our N, this is our A, right? So NA to the power N minus 1. N is 4. Here N is 4. A is equals to 5. So N is 4. A is 5 to the power N minus 1. So this is 4 times 5 cube. So 5 cube is 125. 125 4 times should give you 500. So this is your answer here. Clear? Okay, now let's see another one. Now let's see, this is a to the power x minus 1 by x, which is log base e. And this is natural log. Okay, so don't worry about this because you'll be using natural log only all the time in here. So now what you will do, see this is different, x tending to, this should be 0. Okay, now you see this formula, x tending to 0, a to the power x minus 1 by x. Okay, so this is natural log of a. So you can see clearly here, this doesn't look like this, only this part looks like this, and this part looks like this. Okay, and x is the denominator, right? So this is x tending to 0, this is x tending to 0. Now let's see what I can do here is a limit x tending to 0, 3 to the power x minus 1 minus 2 to the power x. Now this one I am bringing by myself extra. Okay, so can I write plus 1 to remove it? Okay, so why I am doing this is I am trying to bring in this form. So you see here, limit x tending to 0, 3 to the power x minus 1 by x. Can I write? Because x is the LCM for this, all 4. So I have split it 2 at a time. So I'll take minus common from here. So if I take minus common from here, 2x will become positive and 1 will become negative. And there is x. Okay. Now fundamental theorem of limit says what? If you have two functions like this, you split your limit. Limit x tending to 0, 3 to the power x minus 1 by x minus a limit x tending to 0, 2 to the power x minus 1 by x. This is what I am getting. So this will give me what? Log base e of a. A is, what is a here? A is 3 minus log base e of 2 because a is 2 here. Log 3 by 2. This will be log m minus log n, log m by n. Okay, so this you should have done in class 11, logarithms. Okay, so I hope you understood this formula. Now let's go to another problem. Now you see, question is this, but I took a formula this. I didn't take limit x tending to 0 sine x by x equals to 1 because both are same. What I want to explain in this formula is this about this mx. So that's why I have taken this mx1. If you know this one won't be a problem. Okay. Now let's see. limit x tending to 0 sine 6x by x. So can I directly write this one as 1? Think I cannot write, because for me to write 1 here, this x should be here in place of this x should be here in place of this, but it's not satisfying. Here it is 6x, here it is x. Okay, so what should I do? Let's see, what should I do? Now can I do this? Limit x tending to 0 6 multiplied by sine 6x by 6x. What I did is I multiplied and divided by a 6. But the problem is here, this should be 6x. Right? This is x, all should be x. Okay, if these are 6x, this should be 6x. Clear? Either ways you have to see. If this is x, these has to be x. If these are 6x, so this should be 6x. Whichever way you feel comfortable to change, you change that way. Okay, so if I say x tending to 0, okay, if x is tending to 0 and I multiply 6 on both sides, then 6x will tend to 6 into 0. Okay, so 6x also tends to 0. So x is tending to 0, our 6 is also tending to 0, so no problem in writing 6x here. Clear? So I will write limit. You can do just 2 lines, this one and this one. Okay, this one is to make you understand. Okay, now when I got 6 tending to 0, now you can see this 6 is a constant. It can come out of the limit. So I have 6 here, and then limit 6x tending to 0 sine 6x by 6x. Now you see this one looks exactly like this. Clear? Whether x tends to 0 or 6x tends to 0 is the same thing. So now this whole part can be written as 1 according to the formula. Okay, so this is 6 into 1, which is 6. That is my answer. Clear? So next formula is this. So you can see here I have a 5x. Here I have a 5x. Now that 5x is missing here, and that 5x is missing here. Remember that whatever is here should be here as well as here. So that is the condition which should be fulfilled. Okay, so don't confuse yourself, just check whether your x is same everywhere or not. So here what will I do? Limit x tending to 0 log of 1 plus 5x by 5x, let's write. But from where did this 5 came? I brought it myself, so I will remove it by multiplying 5. So I can cancel and get x back here. Okay, now the problem is this one. Okay, so you can write as x tends to 0. Okay, 5x means 5 multiplication will tend to 5 into 0. So you can say 5x tends to 0. So I can directly write limit 5x tends to 0 log of 1 plus 5x by 5x, and this 5 you can see is a constant, so let's bring it out. So this is 5 multiplied by 1, so this is, so 5 is your answer. Okay, so this is how you will do limits. Okay, so this limits I will be using in continuity, so please don't forget it. Okay, see the video nicely, practice these problems, then I'll see you in the video for continuity.